In open systems, there is a flow of matter through the boundary. Sometimes, we like to compare the matter that is coming into the system through the inlet with the matter that goes out of the system through the exit. This helps us to understand how our system has affected the matter. Steady flow process is one type of open system in which the quantity of matter or mass coming in and going out of the system remains steady or stable. The matter has certain properties, like velocity and pressure, which we can measure to see how much our system has affected this matter. In order to do this, our system exchanges some energy with the mass in the form of heat or work done. From the first law, we know that change in internal energy is equal to heat gained or lost minus the work done. But this is a special way of seeing the energy balance because it is specific to closed systems. That is, where there is no mass flowing in and out of the system. So for an open system with a steady flow, we can modify this to include all the types of energies, as change in total energy is equal to heat gained or lost minus the work done. This total energy includes the kinetic energy, as the mass flowing in and out has some velocity, gravitational potential energy as the mass may be at some height, and enthalpy, due to its pressure and volume. Now, the kinetic energy is equal to mc squared by 2, where m is the mass flow rate in kilogram per second, and c is the velocity, which changes from c1 at inlet to c2 at exit. So, the change in kinetic energy becomes kinetic energy at exit, mc2 squared by 2, minus the kinetic energy at inlet, mc1 squared by 2. The gravitational potential energy is equal to mgz, where m is the mass flow rate, g is acceleration due to gravity, and z is the height, which changes from z1 at inlet to z2 at exit. So, the change in gravitational potential energy becomes potential energy at exit, mgz2, minus the potential energy at inlet, mgz1. The enthalpy H is equal to internal energy plus pressure into volume flow rate. But internal energy can be written as mass flow rate into specific internal energy. Similarly, the volume flow rate can be written as mass flow rate into specific volume, which is the same as 1 by density. So, the change in enthalpy becomes enthalpy at exit, mu2 plus p2 mv2, minus enthalpy at inlet, mu1 plus p1 mv1. We can take all the mass terms common, and rearrange, which gives us total energy at exit, minus total energy at inlet, is equal to heat minus work done. On rearranging further, we get the form which is known as the equation for a steady flow process, or simply, the steady flow equation. Depending on the inlet and exit conditions, we can enter values into this equation, and it will show us how the different variables interact. The many different terms inside the total energy bracket can make this equation difficult to remember. An easy way to remember is that matter has the following energies: kinetic energy, potential energy, and enthalpy. The formulas for the individual energies are easy to remember. Then, all we have to do is put total energy at inlet plus heat on LHS, and total energy at exit plus work done on RHS. And we get the steady flow equation.